It's 2026, and the AI coding space is moving at a speed most developers can't keep up with. Every week, there's a new agent, a new demo, a new tool that's supposed to change everything. And most people end up stuck in one of two places. Either they jump on everything early and waste weeks validating tools that disappear 6 months later, or they wait for consensus and quietly fall behind. The 2025 layoffs made something painfully clear. Being good at coding is no longer enough. The real edge in 2026 isn't trying every new tool. It's adopting the right ideas at the right time, after they've matured, but before everyone else standardizes on them. Right now, 3 patterns have crossed that line. First, asynchronous agents that actually finish tasks instead of just responding to prompts. Second, domain-specialized agents, especially for front-end, where generic AI output still looks bad. And third, AI skills and guardrails that turn best practices into something repeatable. In this video, I'll break down all 3, what they are, why they matter, and how to use them without wrecking your codebase. And for the front-end piece, I'll show you the one tool that actually changed how I build UI. Let's get into it. Cursor and Claude Code agents had their moment, but the start of 2026 is very much with Ralph Wiggum. Here's the key contrast with standard Cursor Claude agent workflow. Standard agent mode tries to complete the request in one pass, inside one session. Context windows are always an issue. Ralph assumes the first pass will be imperfect and wins by iterating. You give it a prompt, it edits some files, runs a couple of commands, writes a summary, and then it finishes and exits. Ralph is a loop, and the philosophy is almost stupid on purpose. If the agent didn't actually finish, don't negotiate with it, run it again. And the loop isn't just repeat the prompt. What you're really doing is feeding the agent the consequences of its last attempt, the code it wrote, the failures it triggered, the tests that didn't pass, and the notes it left for itself. So every cycle starts cleaner and more focused, almost like the agent is waking up, rereading the repo, and taking another swing. That's why Ralph is so much better for multi-step work. Instead of one big attempt, you get attempt, fail, learn, fix, verify, repeat. And this is the part most devs miss. Ralph doesn't trust the agent to know when it's done. It uses a mechanism to prevent premature exits. In the Claude Code implementation, it hooks into the moment the agent tries to stop, checks for a completion promise, and if it's not there, it forces another loop. So you go from agent wrote some code and said it's done to agent is stuck in a loop until the work actually clears the bar. That's the unlock. Autonomy with persistence. And that's why it's having a moment. Even mainstream outlets are calling out how this meme technique turned into a serious workflow once models got strong enough to converge over iterations. Now, one caveat, this only works when you give it verifiable outcomes. Make it better is not verifiable. Tests pass, types pass, feature behaves like this is. When you do that, Ralph becomes the closest thing we have right now to the original promise of coding agents. But even if you solve the agent stops early problem, there's still one domain where generic agents consistently struggle to deliver production quality: front-end UI. Here's what's actually broken about AI-generated UIs right now. Most tools work like this. You describe what you want, the AI generates an entire app in one shot, and you pray it works. The problem? Context limits. A real production front-end can easily be hundreds of thousands of lines of code spread across dozens or hundreds of components. So what happens? It forgets the design system you set up 3 prompts ago. It reuses the same component names. It breaks the existing UI when you ask it to add a small feature. I've personally had AI tools overwrite working components just because I asked for a simple UI change. And worst of all, most of these tools generate the same aesthetic. You've seen it, that Vercel style gradient, interfont, 3-column grid, Shadsian components dropped in with 0 customization. It's not bad design, it's template design, and users can feel it instantly. There's also a bigger risk nobody talks about. Most AI tools are full stack by default. They touch your backend, your database, your migrations, even when you didn't ask them to. Kombai does something radical. It stays in its lane, front-end only, no backend, no database, no API generation, just UI. And because it's specialized, it's actually good at its job. Here's what it does differently. First, it has a real planning phase, and I mean front-end planning. You approve the plan before a single line of code is written. That alone kills the "I got 500 lines of JSX I didn't ask for" problem. Second, Kombai works feature by feature, not app by app. Each generation is scoped, previewed, and saved before you move on. No more "the AI forgot what I asked 3 messages ago." Third, and this is massive for real projects, Kombai has human-reviewed best practices baked in for over 300 front-end frameworks and libraries. It scans your repo, understands your stack, remembers it, and generates code that actually matches how your project is written. All right, enough theory. Let me show you what this looks like when you use it the way it's actually meant to be used. Instead of starting from scratch, I added a new feature to an existing dashboard because that's what real front-end work looks like. I wanted to build a revenue insights page, summary cards, filters, a data table, fully responsive. I started in ask mode. Before writing any code, I asked Kombai to generate 3 lo-fi layout options. First, and this already sets it apart, it actually asked about my tech stack instead of guessing and being wrong. I saved it and let it proceed. It gave me 3 layout options, each with the trade-offs clearly explained. This is how front-end decisions are actually made. I picked the second option and switched to plan mode. Kombai broke the feature down into a component structure, state boundaries, and accessibility considerations, all scoped to this one page. I approved the plan and only then let it write code. At this point, it's already scanned my repo and understands how things are structured. And this is the part I really like. It doesn't start inventing new components. It reuses what's already there. It asks me to run a command, I approve it, and it starts wiring everything up, component by component, the same way a real dev would. Once it's done, I spin up the local dev server to see how it looks. And honestly, this is solid. The layout makes sense, the spacing is clean, and it stuck to the design choices I already had in the project. Then I take it one step further and drop in a Figma file as a reference. You literally copy the frame link, paste it in, confirm, and Kombai uses that layout as a guide without nuking your existing styles. And this part matters. I didn't ask it to blindly clone the design. I told it to use the layout and spacing from Figma, but keep my existing theme, components, and Tailwind conventions. It parsed the file, cleaned up messy layers, extracted assets properly, and generated code that fit my repo instead of fighting it. At this point, the page looked solid, but I wanted to refine it visually. So I opened Kombai's user browser, selected a specific section, and told it to make that column visually quieter and improve scannability. No CSS explanations, no guesswork. I literally pointed at the UI and said, this part. Finally, I ran an accessibility and performance audit. Kombai flagged contrast issues, missing ARIA labels, and a couple of small performance improvements, and fixed them directly in the code. From idea to a polished, responsive, accessible feature, without touching my backend, my database, or my APIs. That entire flow took under an hour. And the most important part? It doesn't look like AI UI. No gradients, no template vibes, no generic spacing. It looks like something a front-end developer actually built. But here's where most teams screw up. They have coding standards, but don't enforce them when AI writes code. So you get components that break conventions, tests that skip edge cases, and APIs without error handling. Then someone spends an hour fixing it. AI skills solve this. Tools like Claude Code turn your standards into reusable playbooks that the AI follows automatically. Your team always handles forms the same way. Zod validation, optimistic updates, toast notifications, loading states, analytics. Without skills, you re-explain this every time, and the AI forgets half of it. With skills, you define it once. Now every form follows your pattern automatically. Same for API errors, component structure, accessibility, security, anything repeatable. The shift is simple. Junior devs fight the AI. Mid-level devs prompt it well. Senior devs give it a system and let it run. When AI follows your standards automatically, you stop reviewing code and start architecting features. That's the leverage. Here's the bottom line. The developers who win in 2026 aren't the ones trying every new tool the week it drops. They're the ones who recognize when a pattern has matured and adopt it before it becomes default. Right now, these 3 patterns are in that zone. And notice what all 3 have in common. They don't replace you. They change what you spend time on. Less babysitting, less cleanup, less, why did it do that? More architecture, more product decisions, more shipping. Is any of this perfect? No. You still need taste. You still need to review the diff. You still need to know what good looks like. But these patterns are practical now. And if you adopt even one before your team standardizes on it, you'll feel the gap fast. If you want to try them, I'll drop links to Ralph Wiggum, Kombai, and Claude Skills in the description. Pick one this week. Run a task end-to-end with a finish it workflow, build one real UI feature with a front-end specialized tool, or write one skill that makes your AI behave like your team. Then come back and tell me what broke, because that's where the real learning is. Thanks for watching, and I'll see you in the next one.